Let's continue. So far, we have learned how to evaluate the future and the present value of a lump sum, in other words, compounding and discounting processes. We have also learned how to calculate the future and present value of a series of cash flows. Now let's focus on doing the same for annuities and perpetuities. What is an annuity? This is a specific type of an asset which generates a constant set of cash flows of fixed payments over a certain period of time. It's frequently used by pensioners who make contracts with insurance companies in order to receive a fixed payment for a certain number of years when they retire. For example, £1,000 for 20 years starting from 2025, something like that. There are also formulas to determine the future and present value of an annuity, where A stands for this specific cash flow which we will receive in the future. This is our annuity cash flow. I is our normal interest rate and N is a number of periods. These are the formulas. How do we apply these formulas? Let's consider a series of 5 payments, $1,000 each, which are made at regular intervals when interest rate is 5%. So you invest $1,000 each year for 5 years at 5% return. Because of the time value of money, the first payment is worth more than the second, and so on. Let's calculate how much you would have at the end of your 5-year period. Let's calculate the future value of this particular investment. What you can do here, you can try to compound each of these payments in turn. For example, this payment, the final payment which you make in year 5, will not be compounded because you've just made it, you haven't earned any interest on it. The payment which you've invested in year 4 will be compounded once, so your compounding factor will be raised to power 1, and you will be able to earn 5% once during this final year. So this specific payment will be worth $1,050 at the end of the investing period. This payment in year 3 will be compounded twice because it will generate interest twice in year 3 and in year 4. So you will apply compounding factor raised to power 2 and so on. If you add them up, if you add up the values of each individual payment, you will get $5,525. This will be the future value of this specific annuity. However, rather than calculating each payment individually and then adding them up, you can use the formula which will tell you how much you will get at the end. Straight away, just plug in the numbers. Your annuity payment is $1,000, interest rate is 5%, and number of periods is 5. Apply it, make calculation, and you will end up with the same number. A small difference here, 1 cent difference, is due to rounding. That's how you use this specific formula. We can also calculate the present value of an annuity in a similar way. Let's imagine that we're receiving a series of 5 payments, $1,000 each. You will receive an income, pension, for example, each year for 5 years. And we are trying to calculate the present value. In contrast to the future value calculation, which we've just done, a present value will tell you how much money you would be required now to produce this series of payments in the future. Again, assuming a set interest rate. And what you are doing here in this example, you are trying to bring the future cash flows into today. You are trying to calculate their present value in today's terms. So apparently you will discount each of these payments using appropriate discount factor for each year. And if you add up these values for 5 years, you will get this sum, $4,329. This is the present value of this annuity. It shows us that this specific sum, $4,300 invested at 5%, would be sufficient to produce these 5 payments of $1,000. If we plug in these numbers into the equation, instead of calculating them individually, we would get absolutely the same result. This is how the formulas for annuities work. We can also calculate future and present value of perpetuities. This is another type of a financial asset which also generates a constant cash flow at regular intervals. However, it does it forever. Instead of getting these payments for a certain number of periods, 5 or 10 years, we are getting them forever. For example, a state pension, you will get them for as long as you remain alive. Here, the formula is very simple because as long as the interest rate is positive, the present value of a perpetuity can be calculated by simply dividing the regular cash flow, which you will receive, by the interest rate. Very, very simple formula. For example, what is the present value of an asset which will generate £1,000 income forever if an expected interest rate is 5%? Its current value is £20,000. So this is what you might be prepared to pay to get these payments forever at this existing interest rate, this rate of return. And the final application of compounding and discounting concepts is calculating the period of time which is required to achieve a certain financial goal. Let's have a look at an example. Let's imagine that you've been trying to save to buy your own home. The total cost is going to be £100,000. This is what you plan to spend, and you currently have about £5,000. If you can earn 5% return on your money, how long will you have to wait without making any further contribution? Or how long will you have to wait if you manage to get 10% return on your investment? Let's check how you can do this. From our basic present value equation, which we've learned in the beginning of this lecture, we can plug in our numbers. Our present value, what we have at the moment, is £5,000, our current balance in a savings account. We need it to grow up to £100,000. Interest rate I is 5%, 0.05. We need to calculate to figure out the number of years. If we plug in our numbers into the formula, we will get 5,000, which is equal to 100,000 divided by 1.05 raised to a power n. This is our unknown, which we'll try to find. This implies that this term will be equal to 20, and now we'll need to solve for n using algebra. If we do these calculations, we will get an answer 61 years. So without further contributions, if you will start with £5,000, you will need to wait for 61 years before your capital will grow to the required sum. Apparently, it's too long. You don't really want to buy your first home in 60 years' time. It's just too long wait, which means that this particular plan, just growing your existing capital without any further contributions, is not viable. You'll need to make certain adjustments. If you manage to get a higher return, if you invested at 10%, solve it using a new number for interest return, you will get 31 years. Again, the length of time required to achieve your financial goal is too long, which means that you again need to make further adjustments. For example, you might need to make additional contributions. So 5,000 is not enough, so you might need to save more in order to achieve your financial goal in a decent period of time. So this is the final application of compounding and discounting, which you can use in your personal financial life. So quite a lot of formulas, but these concepts are very important, and hopefully you will be able to do quite a lot of exercises in your seminars and you will be able to understand these concepts better. Thanks a lot for joining me today. Bye-bye.